A growing lunar base requires a way to distribute power from generators to end users. What are the options and which startups are working on the technology? Let's look at the subject of power distribution on the moon. Astrobotic is working on the first commercial lunar power grid for the lunar surface. A demo of their Lunar Grid Lite technology is almost ready to fly, although no launch date has been announced yet. Fibertech is working on optical power beaming solutions, and Volta Space is developing lunar power satellites to beam power down to surface assets. We'll cover these projects along with a NASA study on lunar power systems and an alternative to power grids. Hey everyone, quick thing before we dive in. If you leave a comment on this video with your thoughts or opinions, it could get highlighted and read out loud in my weekly live stream this Saturday. I recap every video I publish this week with all the slides, images and extra clips you might have missed. Then I pull up the comments section, read some of the best ones, maybe even yours, reply live and answer chat messages. The more people chatting, the more fun it gets, and yeah, super chats definitely get priority. So drop your comment right after watching the video, and I'll see you this weekend for the full recap and live Q&A. Find the live stream link in the pinned comment for this video. Okay, back to lunar power grids. Let's answer a question some viewers may have about lunar power distribution. Is a power grid necessary? NASA thinks so. In fact, and I'm quoting here, power is the key commodity needed to exploit the lunar surface. When you think about it, it's obvious really. The moon is cold and dark. Without heating and lighting, it's impossible or very difficult to do anything. Energy is needed for any activity on the moon. First, let's quickly clear up the difference between power and energy, because they're not the same thing. Imagine a garden hose attached to a water tap. Power is the flow rate, how many gallons come shooting out every second. Energy is the total amount of water that flows out over time. For instance, the gallons you collect in 1 hour. In electricity, it's exactly the same. Power is measured in watts or kilowatts. It's the instantaneous rate of delivery. Energy is measured in watt hours or kilowatt hours. It's the total you actually get to use. Think of energy as the bucket of water and power as the flow rate through the hose pipe. The lunar South Pole, a key region NASA wants to explore, has areas with up to 100 hours of darkness, with some craters being in permanent darkness. Extracting local resources, such as lunar water ice, will require not just good lighting, but energy-hungry excavators, haulers, and processing facilities. A permanent or long-term base needs heating over the 14 days of lunar night and cooling during the lunar day. Rovers, communication equipment, computers, scientific instruments will all require power. Without a power grid, each piece of equipment needs its own onboard power system, making it heavy, expensive, and complex. Many lunar-based concepts I've covered on this channel require around 60 kilowatts of power for a crew of 4. Add in other equipment and you can see the energy needs quickly scale into hundreds of kilowatts, and that's before commercial mining begins. Without a grid, activity must be limited to illuminated areas and only during the lunar day. Okay, let's move on to a promising solution to deploying power to where it's needed on the moon. DC to DC microgrids. This is the approach NASA considers the baseline for the Artemis base camp. The reason NASA wants a microgrid on the moon is to avoid future science missions needing their own onboard power. Power grids are flexible, scalable, and reconfigurable. Power can be uprated or downrated individually for each piece of equipment. New power sources such as solar or nuclear can be added at any time. One issue is that end users must adopt the same power interface to hook into the power grid. Multiple local microgrids can be deployed, for instance one for the base camp and separate systems for regions with mining and processing facilities. The main bus, a copper cable, would run at a high voltage, around 3 kilovolts. This provides high efficiency and low mass over long distances. Each piece of equipment plugging into the grid would have its own DC converter to step down the voltage to whatever is required for operation. Rovers, for instance, would use a few hundred watts, while a habitat could use 50 kilowatts. Cables can be a few hundred meters in length to 10 kilometers or more, conducting electricity at 90% efficiency. Once lunar resource harvesting and processing has started on the moon, cables supplied from Earth can instead be made from lunar aluminium, which is a good conductor and easily available from lunar soil. The Lunar Grid Light demo by Astrobotic will unspool a 500-meter high-voltage DC cable and then transmit 1 kilowatt of power for the first time on the moon. The flight hardware is now in production and will be ready to fly to the lunar South Pole this year. The starter infrastructure for the Artemis base camp is likely to be several lunar landers with deployable vertical solar array towers. Small cube rovers from Astrobotic deploy ultralight high-voltage DC cable and wireless chargers to build the first expandable local microgrid. Astrobotic recently announced a partnership with Honda to integrate their regenerative fuel cell system with Astrobotic's vertical solar array towers and Lunar Grid system to provide continuous power during the lunar night. During the lunar day, the Lunar Grid provides power to the fuel cell system to split water into hydrogen and oxygen. During the lunar night, the process works in reverse. The fuel cell system combines the hydrogen and oxygen back into water, generating electricity which can then be used to provide power to the lunar grid, resulting in a power system that works during the lunar day and night. Okay, what about other methods for distributing power? Power beaming, surface optical. Laying cables isn't the only option though. It's possible and highly efficient to beam power using lasers. Without an atmosphere, losses are reduced, although line of sight is needed for this system to work. FiberTech is working on optical power beaming systems for the moon. Their LION system, which stands for Lunar Infrastructure Optical Node, is low mass with a high power laser on the top of the device, capable of providing power as well as position, navigation and timing signals. FiberTech pitches their system as perfect for permanently shadowed regions, such as Shackleton Crater. Instead of unspooling cables to the crater floor at a depth of 4 kilometers, why not beam the power down from the rim? To be honest, this would only support scientific analysis or demo mining operations. For commercial exploitation of resources in a crater, nuclear reactors rated in the megawatts or gigawatts would need to be deployed to the crater floor. Rovers with an optical light port, such as a Volta rover shown, could be powered by an optical power beaming system. Volta will be testing their light port receiver on Blue Ghost Mission 2, due to land on the moon later this year. A full LION system has a mass of 360 kilos and outputs 5.9 kilowatts of power over a 20-kilometer range. End-to-end efficiency is around 20%. Okay, let's move on to look at nuclear reactors. NASA will be deploying a 100-kilowatt reactor on the lunar surface by 2030. Nuclear reactors connect to power grid or use beamed power. From a NASA technical paper by Jeffrey Landis called Laser Power Beaming for Lunar Polar Exploration, which I've linked to in the video description, comes the idea of using power beaming from a nuclear reactor as an alternative to laying down cables. The problem with nuclear reactors is that they must be sited away from habitats to avoid radiation exposure. A reactor of the size NASA intends to deploy will need at least 1 kilometer distance from the base camp with a 2 kilometer exclusion zone. Instead of sending and unspooling kilometers of cables, why not beam the power to the habitat? The LION systems from FiberTech are lightweight and can be mass deployed to provide power where it's needed. The paper suggests siting a nuclear reactor on the rim of a crater, say Shackleton Crater, with lasers beaming power down to equipment on the crater floor. Lighting, rovers and mining equipment can be powered without needing any cables. Volta Space, a space startup working on power beaming for the moon, have said their technology can extend the reach of nuclear reactors by transmitting generated power using their laser system. Talking about Volta Space, their plans extend beyond surface power beaming. Beamed power from lunar orbit. In fact, Volta plan an orbital laser constellation around the moon with commercial service starting in 2028. Surface assets, such as rovers or landers, will need to be fitted with a light port, which has a mass under 2 kilos. The first lander to have this port is the Blue Ghost Mission 2 lander, which will test the light port using the sun as a source of optical light. Beamed power from lunar orbit complements local microgrids and provides global coverage of the moon. A light port receives over 100 watts of electrical power, 45% efficiency. That's over 5 times the power from radioisotope devices and only 1/10 the mass of the smallest battery capable of surviving the lunar night. Volta Space has partnered with iSpace US to integrate a light port receiver onto an iSpace rover. This will extend the lifetime of the rover, allowing it to survive the lunar night and resume operations once the sun comes up. Okay, let's look at a recent NASA study on this subject. From a 2022 NASA study on lunar power systems, the authors make the case for DC microgrids and power beaming for power distribution on the moon. Nuclear power is considered the backbone of the system, with power transmitted through direct current cables. Power beaming can extend the microgrid with orbital beaming for anywhere, anytime coverage, needing only the installation of a lightweight light port receiver on surface equipment. The lunar grid can start with only 1 to 5 kilowatts for science missions and scale up to hundreds of megawatts to support a lunar economy. Okay, with power grid options explained, let's consider one alternative approach. Quick alternative to lunar power grids: early lunar base only. Using tall, self-deployed lunar masts, such as Honeybee Robotics' Lunar Sabre masts, could provide an alternative approach to using microgrids. These masts act as standalone power stations or recharge stations. Rovers or other assets with onboard batteries drive near a mast to recharge wirelessly and stay warm during lunar nights. This avoids the need for long cable runs or full interconnected microgrids. Instead, masts are placed around the key areas of scientific interest. In addition to wireless charging, a 100-meter tall Lunar Sabre mast can hold 1 ton of payload on the top deck, allowing for multiple beam directors to power systems at long distances. The lunar masts come in a range of sizes, with the largest and most powerful system towering at an impressive 100 meters in height. One of these masts could power rovers or other equipment to distances of 20 kilometers or more. Near the lunar South Pole, a 100-meter mast would be illuminated by the sun 94% of the time. With batteries integrated, they could provide power 24/7, including the brief intervals when the sun is below the horizon. These masts would solve the lunar night survival problem. Just park the rover next to a mast and receive power to prevent freezing. A network of distributed Lunar Sabre masts could provide an alternative to extensive cables for power distribution over extended distances. Final thoughts. For a growing lunar base, power needs to be distributed somehow. Each mission providing its own power system is not a scalable approach. The most likely method will be high voltage DC microgrids for each base or outpost, with additional grids at mining or processing centers. These local microgrids can be extended with power beaming, either from ground stations or from orbiting power satellites. A number of space startups are working on power distribution technologies already. Astrobotic is developing their lunar grid system with a prototype ready to fly this year. Volta Space's light port receiver flies on the next Blue Ghost mission from Firefly. Fibertech provides power beaming devices for the moon, and Honeybee Robotics has developed the Lunar Sabre mast as an alternative to laying cables. iSpace US is partnering with Volta Space to survive the lunar night. Honda is partnering with Astrobotic for a 24/7 power system using their fuel cell technology coupled with Astrobotic's lunar grid system. With nuclear power reactors, the backbone of any power grid, likely to be deployed to the moon in the coming years, lunar missions are likely to have plenty of power in the future. What do you think is the best approach to power distribution on the moon? Should we start with lunar masts and power beaming, or lay down high voltage DC cables? How about anywhere, anytime power using orbiting power satellites? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Watch the weekly live stream to see the images, clips and slides from this week's videos. It's a live Q&A on this week's space topics where I read out loud some of the best comments. The more people join, the more fun the live stream is. Be sure to like and subscribe so you will see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.